Ugh. Heavy inertia. A room full of incomplete projects. A room where projects go to die. One of my little dead projects. Oh, it's kind of a crazy idea, but I wanted to fix this battery charger. And basically this charger worked, but it works real poorly like a lot of these chargers do when they get older. You only get like 1 amp out of them, you know. What's happened is the selenium rectifiers, which are these two plain things on the side, end up with high ESR. They get internal resistance in them, and they stop dropping more and more voltage. The forward voltage gets higher and higher. Normally, when they're functioning correctly, the forward voltage is quite a bit higher than a silicon diode. It'd be like 5 to 10 volts. Silicon diode might drop a volt under load. You know, we think about 0.6, that's like a light load. Under a heavy charging load near its rated current, we'd be dropping a volt or even more. And these numbers were kind of pie in the sky. They were probably vacuum tube days type numbers. The selenium rectifiers were 85% efficient, where vacuum tubes were 60% efficient. And they're talking like probably a 350 volt power supply for a vacuum tube circuit, where chopping 10 volts out of 350 volts, you know, well, maybe it's not that inefficient. But you chop 10 volts out of, you know, maybe 30 volts from this transformer or whatever, you know, and well, your efficiency's way down there. But this is real typical of how these things go. You can't get much charge out of them, you know. You measure them, the voltage right out of the leads coming out of them, they got 12 volts. But you put a load on it, you know, or a battery to charge on it, and they just never pull more than an amp or so. That's because they've got high ESR. So anyway, the obvious thing would be to put a couple of diodes in here. But I really hate this type of circuit. It's real popular in the old days because rectifiers were expensive. And you know, before I get into that, it's kind of odd, these battery chargers with selenium rectifiers. You'd think that something that would fade out, you know, like in the 70s was the last what they did it. Well, no, it's not true. They actually had some production until recent vintage, actually. And they have a short life. They go high SR, so maybe it's planned obsolescence, I don't know. The other thing is when they do die, I think the one reason they used them is because they're pretty short resistant in this application. They got them oversized to the point where they don't blow up real easily if the thing is shorted. That must have been part of their thinking, I don't know. When selenium rectifiers do fail, they release a toxic gas. It's supposed to be really obnoxious and very poisonous gas. So I've never been around when that happened, but the normal mode of failure is the slow ESR just keeps rising with age. More and more voltage drop. So back to this anyway. I've always hated this kind of design where they use 2 diodes off of a center tap transformer instead of using a full, you know, bridge rectifier, which is, you know, a lot more better way to go. You're loading the transformer for the whole cycle. Here you're loading it for half the cycle. Well, I guess you're using half the transformer one half the cycle, using half the transformer the other half the cycle, I guess. I don't know, I just thought it was a little flaky. It's not making poor use of the transformer. If I put a bridge on it, I would actually get more voltage. I'd actually get double the voltage. So what I started to make here was a power supply that could actually charge 2 batteries at once. You know, a 12 volt battery here and a 12 volt battery here. The other detail of this circuit on the input is the way it does the 6 and 12 volt output is done on the input. So this might be a saving grace for me. I'll have to see how it works out. I'm really just going to have to try this thing out and see how it goes. I could measure the transformer. That's probably what I'll do next. Power this thing up and measure the actual height on the transformer and see what I'm actually going to get here and go through that kind of calculation. But I'm going to get what I'm going to get at this point. I didn't really know how to draw a selenium rectifier, so I just kind of drew these long lines. And on the center tap, this is a thermal breaker, and this is an amp meter on the front panel. Each of these selenium rectifiers just go to ground, and there's a common lug goes to one of the outputs. So that's pretty much how the circuit is currently. And I'm going to make it into this circuit. I see I was going through a spat of 12 volt solutions. This little Harbor Freight useless thing. These are pretty piss poor actually. They do work if you baby them and never short them. They're not really short proof. They will die. And they're chintzy. If they're exposed to UV light, these break down real fast. Ends break off real easy. They're not strain. There's no strain relief on anything, you know. It's just kind of piss poor. I mean, it does basically work, though. If it's cared for. If it's inside of a garage, maybe it's good enough. You take care of it and be careful with it. Then where's the other one I had just found here? A little switching regulator power supply I use. And put clips on it. That was kind of hilarious. Where'd that go? Then I started working on this old dog because it wouldn't charge. It only give me like half an amp of charge or amp and a half on a really dead battery. Just didn't go anywhere. And then I found this old dog, and this is something if I recall right, I bought it at a garage sale back in probably my late teens or early 20s. Put a bigger transformer in it. Hyped it up in a number of ways, and it's got a thermal breaker in it, so it survived. Put a green neon in it. It's been old faithful, and after I found this thing, I rediscovered that I had it here. Hell, this project just kind of got scrapped. But I'm going to get it off the bench and finish it up. I may have some other uses for it. I had to find the other set of wires I had made for this project. They'd gotten stolen away. They were wrapped around Old Faithful power supply, though. With the 612-volt switch set to 6 volts, the output of the transformer is 17.8, I believe. Well, you believe me, it was 17.8. But what's interesting is it doesn't hum. It's completely silent on this setting. Whereas I go to the other setting and it is noisy. Power. I'll have to look at the transformer a little, make sure nothing's loose. Nothing can be crimped down or wedged or anything. I'll solder this clip back on too while I'm got the soldering iron going. Otherwise, I believe this guy still works. This Harbor Freight trickle charger. Yeah, I have all these battery chargers around because when I was working, I had my work truck here, big giant bucket truck. Got a million different things powered. If you leave one thing on, you might come to a dead truck in the morning. That's embarrassing. You're getting a slow start. You know, we started off at the computer in our truck anyway, but yeah, a couple delays getting the truck started here and there. And my truck battery is going bad too, a couple times. They don't last that long over the years under that heavy use. So that's why there's so many 12-volt battery chargers and 12-volt devices around. Trying to get my truck started in the morning. Thank God those days are gone. I miss the job, but not the stress of getting going, getting out, going out in the rain and the snow. The worst parts of it, really. Extreme heat, extreme cold. Got carried away and burnt my breakfast. Oh well, need a math break here anyway. I don't see a calculator in this room though. All my little cheapo dollar store calculators that I've bought, I don't have one in this room. I still need to buy another one. So I measured the voltage. There's that switch for 2 different windings. It runs dead silent. I thought the wasn't even working. I thought when I had it on the 6 volt because it was dead silent. When I have it in the 12 volt, it hums like a mother. It's like a night and day difference. So I got the 2 different readings across this transformer: 26.8, 17.08 volts RMS, multiplied by the square root of 2 to get the peak value. That's actually going to be peak to peak value, minus 2 times the voltage of the rectifier diode. And 0.6 is low. That's a real low current. You know, that'd be like here I'm measuring your low current. When I set a 1 volt up here for a silicon diode, excuse me, that's under load, you know, drawing like an amp through it. But at a lower current, you know, it'll be like 0.6 volts. So that's how I get all that. And I just got to crunch out the numbers here. A quick look at the math here. Kind of made it a little messy because I put a /2 under all these. Because I'm only going to be, I want to see what the voltage is for half the voltage basically. So I'm going to be using it in this configuration, which will have up the voltage. So I calculated out my full voltage, converted it to RMS to peak, subtracted out the rectifier, divided by 2, got that number. For both the low voltage setting, this is a 6 volt setting, and the 12 volt setting. So my 12 volt settings would be more like 18 volts, my 6 volt settings would be more like 11.4. So it's going to be a heck of a battery charger. But I've got other ideas in mind for it. Plus at the low setting I probably could put it on a 12 volt battery and get it up to that point anyway. Maybe attempt a fast charge. I wonder what it'll actually do under load. It'll be interesting to see what the actual, and these are unloaded conditions here that I'm using. Interesting to see how high it actually gets. So before I get to this big project, I first got to determine what I was going to use for a full bridge rectifier, and I think it's going to be these guys. I don't see anything else around here that would qualify once I scam it out of something. I believe that's why I had these here. I guess I'm just going to go with them. The iron I've got here is kind of neat. It's got little LEDs in it. It's a Weller. It's a little cheapy guy. But it's not hot enough to really get these clamps warm quickly for soldering. So I've spread the little jaws here that held the wire tight before it broke. I was going to try to find some heat shrink tubing to put over the end of that wire just to give it a little strain resistance, but I just don't have any heat shrink around here that would fit the bill. I don't have much here. I'll take a second look. But what I'm going to have to do to solder it with this little iron is to actually hit this with the lighter and get it hot, and then finish it off with the iron real quickly. So I'm not going to capture it on camera, being that I don't have a tripod anymore. But I'm going to put flux on the wire first and heat it with the lighter, remove the old wire, jam the new wire in, solder it as quick as I can. A shop without heat shrink. Who'd have thunk it? Disgraceful. Anyways, back together as good as they were originally. No better though. Tied all my grounds together. I think I'm going to solder it. I'm not going to wire nut it. Already got rosin on it. Central ground plexus. Adding a couple old capacitors. They're a new old stock. They were prime, but I bought these a long time ago, decades ago. And my little plexus was above the ability of my soldering iron. Again, I had to preheat it with a flame and put a glob of rosin on it and hit it with the iron. I did get it to flow really well though, so it's not cold. So I built a bridge rectifier out of these 4 rectifiers of unknown origin. I believe these are rectifiers that I bought in bulk a long time ago. Kind of unmarked generic things. And they failed me on a project I used them in, so we'll see how they do here. They're high current, but I used them in a project that didn't require that much voltage. Hopefully this is even less voltage than that project was. And hopefully they won't blow. If they blow, then at least I'll know, I guess. Otherwise I gotta scrounge some, but I'll have small leads in most stuff I have. These would do, scrounge from cable equipment, but if I had more of these would work, but I don't have enough of them. There's the rectifiers soldered onto the AC leads. I guess I'm just going to power it up before I go any further and make sure these things can hold the voltage. Okay, she's plugged in. The rectifiers have not gone up in smoke yet. So I got 17.5 roughly across them. They're holding just fine. I'm going to put them into the circuit. Positives on the right. All built, as good as they get built tonight anyway. Got my bridge rectifier. Caps. I'm going to tape it all up, but I wanted to show everything before I taped it up. I put these two wires together with a wire nut because the one missing element in this whole plan is I've got no protection on the one rail. So I go to this circuit here that I built. This is mostly correct except that on the positive side I've got this, what I show in the original circuit here, the thermal breaker and the meter, amp meter, are inserted right here where I erased it. I've got protection on that leg that was built into the unit, but I have nothing to protect this leg at all. So temporarily I put wires in so that I could put some kind of protection, probably a fuse. Actually, what I'm really looking at doing here is 12-volt automotive light bulb in here. I don't have one here though. A common, double filamented bulb, and I'll use both filaments, tie them together like I did in my one video for a current interrupter. So I think I'll have a bulb on this side of the line. It should balance out well against the thermal breaker and the amp meter. So I'm going to put together as it is for now and just be careful with it and not short out that bottom leg. But yeah, I need some protection on that. Make this thing more robust. Oh, look what I found. That'll do for my current limiter. Couldn't do much about the hum. It's really strange that you go to 6 volt, silent. But the transformer is kind of fragile. It's very old and dry, and I really don't want to hassle it too much. And I don't have a pair of channel locks handy where I could have crimped the outer case a little bit. Still might try to do that at some later time. But I put it all back together, and she's working. I've got the light bulb on the one rail, the negative rail, current meter and thermal breaker on the positive rail. So it's pretty well protected. And I got a dual power supply. Can actually charge 2 batteries at once pretty heavily, or you can put them at 6 and start them and get them almost up there and then give them a quick jolt on the high side. Let's see what the voltages came out as at. We got 1807 on the negative rail, and I got 1809, 1810 on the positive rail. So they're matching up pretty well, real well, considering that the protection is a little different. I'm going to call this done. Get it off my bench. Projects I really wanted to work on were a couple LED projects. This guy, I really like to get it going again. Got that one. I got another Harbor Freight one I bought to replace it when it failed suddenly, and the new one never worked. Anybody have any information on Harbor Freight spotlights with the LED heads, let me know. I'll have to dive into that next time I have some time here.